some function. If I wanted to visualize what the rate of change of this function was doing, I might want to sketch a derivative, a graph of the derivative without any specific numbers. Even with some, I guess we do have a few numbers on there, but I'm going to kind of ignore the numbers. We can get a general shape of the derivative and tell the trends of it by picking at key points. So this point, for example, the slope, the instantaneous slope at that point would be 0. As I approach that point, my slope is positive, and then it becomes a little less positive, and then it becomes a little less positive, and then a little less positive, and at that exact point, it would be horizontal. And then immediately after that point, the slope's negative, and then it becomes more negative, and then it becomes more negative. So the derivative at this point is 0, because the slope at that point is 0. To the left of that point, my slope is positive. And to the right of that point, my slope is negative. The function itself is positive the whole way, but the slope is positive on this side, the slope is negative on this side. At this point right here, it looks like it's actually the most negative. So I might want to kind of denote that the slope looks the steepest, but in the negative direction. And then at this point again, the slope is 0. So my derivative would be 0. And my slope is negative still on the left. But to the right of this point, now the slope is positive. And as we trend, the slope is positive, but it's becoming less positive. Okay, so those are sort of some key things to notice if I were going to try to draw a picture of the derivative. So my derivative starts off positive, and it looks like it's more steep here than it is here. So I'm going to start at some high positive value, and then it gets lower and lower and lower, and then at this point the slope is 0, so my derivative function should be 0. At this point it seemed like it was like the most negative, so I might mark some point to be where I turn around. And then my slope becomes less negative, and then it's back to 0. And then the slope is positive, and it stays positive, but then it starts to taper off. Probably about right here, it's starting to, it looks like it's getting more steep, more steep, more steep, but then it's becoming less steep at some point and kind of flattening out. Okay, so my derivative function might, that's a good representation of its shape. I mean, I didn't worry about the exact values of it, but in terms of its shape, that's a pretty good representation. So again, my slope started off positive, so I drew above the x-axis. At this point, my slope is 0, so I should be crossing the x-axis. At this point, my slope is negative, so I should be below the x-axis. Here, it looks like I reached the absolute lowest because it's the most steep in the negative direction. And then it stays negative, and then at this point, it's again 0. And then it's positive, and it stays positive until it flattens out, and we're done. Okay, so we'll do more activities like this, but this is kind of one of the things that you need to sort of do at the beginning, thinking about derivatives and what they tell you about your function and so forth.